Hi guys, it's Kumar, and I hope you all had a great start to 2018. Today, I want to talk about a question in factorization. Okay, I know that I've discussed this topic before and specifically about divisibility. We had done a question where we had looked at the divisibility rules of 11 and 9. Today, I want to discuss a question that requires a little bit of out of box thinking. Knowing, being very strong on your basic concepts will actually help you solve this question. So let's look at this question. We are given four variables, and it is said that it is known that A, B, C, and D are positive integers. Okay, take this into consideration. They are positive, they are integers. And after that, we have been provided three equations. First is that A cube is equal to B square. Second, C square is equal to D. And third, D minus A is equal to 5. And we have to use these three equations to find the value of A, B, C, and D. So if you haven't seen this question before or you want to solve it, you can pause the video now and try it out. And after you have done and tried it, you can come back to the solution. So I'll wait for you to complete it. Okay, I'm not going to wait. I hope you have actually paused it and done it. Now I'm going to talk to you how to solve this question. Okay, so whenever we are solving equations, especially equations of these form, we always have something that we follow, that if we have four unknowns, we should have four equations. Okay, one of the issues with this is usually applied when you have a system of linear equations, right? Linear equations meaning that all your variables are linear. For example, see, A has a degree of 1, D has a degree of 1, D has a degree of 1, right? Even if some variable has a degree of 2, we can solve it using the linear equation system, but it should always have the same degree everywhere, which we see is not the case because A has a degree of 1 here and A has a degree of 3 here. Even if all of this is taken into consideration, we see that there are only three equations. So something should tell you that this requires a little out of box thinking to find out the values. Okay, now let's start with this equation. I have D minus A is equal to 5. I'm starting with this because see, there is equation 2 that tells me what is D, and there is equation 1 that tells me A, right? These are the two variables that have been specified in separate equations as well. So I want to start with the third equation and see how, if I input the values from the first and the second equation, that helps me. Okay, now if I combine the second equation with the third equation, I can replace D with C square, which I directly get from the second equation. Okay, and A, we have to slightly modify the first equation. We had A cube equal to B square, right? So I can write A is equal to B to the power 2 over 3. So this is nothing but B over B of 2 over 3, which is equal to 5. Okay, now see, this is where the first technique has to be applied. I can see that this is nothing but C whole square, and this is B to the power 1 by 3 whole square, and this is equal to 5, right? I'm going to apply the basic formula that all of you must have studied of A square minus B square. This is nothing but A plus B into A minus B. So this becomes C plus B to the power 1 by 3 into C minus B to the power 1 by 3 equal to 5. Okay, let's continue the same on the next page. So at the end of the first page, I had got two equations. I had C plus B to the power 1 by 3 and C minus B to the power 1 by 3 equal to 5. Okay, Now you say that, okay, this is just one equation, right? Let's call this equation 4. Why did I say there are two equations? Okay, so the reason being that is, see, I know that c and b to the power 1 by 3 both are integers, right? Similar is the case here. It means this term, let me call it big X, and this term, let me call it by. They are both integers which have been multiplied to get a value of 5, right? Now if you see, there are, since 5 is a prime number, there are not a lot of multiples of 5. So the only possibility is I can multiply 1 and 5 to get this value of 5, the product of 5. Also I can say that because x is having c plus b to the power 1 by 3 and y is having c minus b to the power 1 by 3, x is 5 and y is 1. This is the only possibility possible. So what we are eventually getting is that c plus b to the power 1 by 3 is 5 and c minus b to the power 1 by 3 is 1. If you add both the equations, you'll get 2c equal to 6 and c equal to 3. We have been able to find our first value. Okay. If you put this into this equation, you will get that b to the power 1 by 3 is nothing but 2, which tells me that b is 8. Alright, let me see if I can find. I know that d is c square, which means it's nothing but 9, as I know c is 3. And let's look for a. This is equal to d minus 5. So this is 9 minus 5 equal to 4. So a is equal to 4. This is the only possibility that you'll get with these set of equations. So if you can find any other set of values, please let me know. Please comment. I don't think there is, but if you can, please let me know. Another thing that I want you to think about is that I said that c and b 1 by 3, b to the power 1 by 3, both are positive integers. I want you to think that, okay, c is given to be a positive integer, but why is b to the power 1 by 3 I can directly assume to be an integer? Please think about it and comment on my account, and have a good